Hello, Matt G for IYT here, and today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 15, which reads: a quartz crystal A has an equivalent circuit which includes a diode, 2 inductors and a single capacitor. B will resonate at several design frequencies selected by an adjustment on the side of the crystal holder. C has a single resonant frequency, whether series or parallel depends on the manufacturing process. Or D has series and parallel resonant frequencies with the associated circuit design selecting the one required. So let's run through these answers and see which ones make sense. So we've got A has an equivalent circuit which includes a diode, 2 inductors and a single capacitor, and while a crystal, like many other components, will have an equivalent circuit, we can look that up in the full license manual here, and we can see that it consists of a capacitance in parallel with another capacitance, an inductance and a resistance, but there are no diodes here, so we can rule that option out straight away. Option A is gone. B will resonate at several design frequencies selected by an adjustment on the side of the crystal holder. Well, let's have a think for a second about what a crystal is for. And a crystal is normally chosen when you need it. You need a very specific frequency. So really having a single crystal operating at multiple different selectable frequencies isn't really a thing. You could achieve that with multiple crystals and switching them in and out of circuit. For instance, older designs of transceivers, for example, or like 2-meter transceivers, could have crystals for different ends of the bands or different channels, but that would be multiple crystals. That wouldn't be a single crystal with switches pulling it either way. You can pull crystals by varying the capacitance around them. You can pull them sort of either side of their design frequency, but there's certainly no adjustment on the side of the crystal holder, which will there certainly aren't several design frequencies, which is what that answer is looking at. We've then got C has a single resonant frequency. That's looking quite good so far. Whether series or parallel depends on the manufacturing process. And series or parallel here is talking about the configuration in circuit where that crystal is used. So is the associated capacitance that is generally used with it, I think it's about 20 or 30 picofarads that needs to be supplied in circuit, whether that goes in series or parallel with the crystal. And let's take a look at option D, because that also talks about having series or parallel resonant frequencies with the associated circuit design selecting the one required, and it is in fact option D here which is the answer, because whether the capacitance is supplied in series with the crystal or in parallel is going to select the particular resonant frequency that it has. Now, looking in the full license manual, it does actually call this out, the frequencies, the two different frequencies you get from the series or parallel configuration are normally very close to each other by about 0.1%. Now, on a crystal, for example, for the 2-meter band, that 0.1% could be as much as sort of 140, 150 kilohertz. So that's a few channels up or down. So it does matter when you're designing a circuit with a particular crystal, that you choose that particular resonant frequency, and that is determined by the circuit design and where the capacitance that goes alongside it with. So it's not the manufacturing process that determines that, but it is the circuit design that the crystal is used in. So we'll select option D as our answer here. Let's take a look at the answer key, see if we've got that right, and we can see, yep, for question 15 we've got option D, which is the correct answer. Thank you very much. I'll see you for the next one.